So today I figured I'd start digging into this old desk calculator I got from a surplus auction several months ago. Haven't had a chance to look at it yet. It's possible that there's nothing even wrong with it. Um, I just don't know, and it's one of those things where if you go plug in the power and it lets the smoke out, you're just kind of screwed. Custom silicon in here, never going to be able to replace it, so I figure I'd better take my time and go through this thing properly. With at least making sure like the power supply and stuff isn't feeding excessive voltage anywhere that it shouldn't be. So I've already taken the screws out. There's just 4 on the bottom. Once you lift the top of the case off, that's inside the machine. The whole thing is kind of built into this. It's kind of built into this. I don't know if it's a 2-part chassis or if it's actually connected down in there somewhere, but there's 2 metal sides and everything kind of slots into that one way or another. Several boards in here. There's kind of the Nixie tube board itself here in the front. Slots into what I imagine is a board that has something to do with the driver driving the Nixies. You can kind of see the edge connector back there. There's presumably a power supply board. That's all the big caps and transistors to run the voltage regulation, and back here there's kind of the more chassis mount power input components, the transformers, and wiring, and line filter, fuse, circuit breaker on this actually, but down in the bottom there's kind of a logic board with custom Compucorp silicon on there. It's all pretty old stuff, I think. I don't actually know how old this is. I haven't done a lot of research on it. I think there's actually a second board underneath, if I'm not mistaken. So there's actually a second board in the bottom that contains more custom silicon, and the keyboard here, aside from being a little dirty, I think I want to get this crumbly, decades old foam out of here first. The stuff is just going to fall apart and make a mess, so I'm going to get that out of the way and then start disassembling this thing and seeing what I'm dealing with here. Power supply is generally the first section you want to look at. If there's something wrong with that, it could take out the rest of the machine, and whereas everything else will just kind of, if it's broke, it'll stay broke, but it's not terribly likely to break anything else. So power supply will be the first place I look over here. Okay, so it's mostly disassembled. Like I said, there were 2 boards in the bottom. They sort of slid out of a small backplane that's up here in the front. Some edge connectors. Left the keyboard in. It's not really in the way. The Nixie display module kind of came out as one piece, and the power supply regulation board came out as well. So these connectors here. Left all the transformer and the line input circuitry kind of in place. I've got just about everything disconnected from it. I did wire in a different, I used this line filter to get for the connector basically, because the original plug is that thing, and I have no clue where to find a cable for that thing. Even if I did, aside from the usual channels like eBay, I'm not waiting to get that shipped here, so I wired in a plug that I do have, which is just an IEC cord. So I went ahead and got out my Variac, and I've got that set on just minimum voltage here just to test stuff. So I've got it on about 10%. It's measuring 14 volts. And when I plugged it in and started cranking up the variac, I got nothing on the output of the transformer. So I went back one level further and I checked, do I have voltage at the fuse here, the circuit breaker rather. I'm able to do that if I pull off this little plug for the voltage selection. You see this is for the 115 volt variant. This pin here is for the one end of the line cord, and go ahead and plug it in now. Can verify that I have AC at the output of the line filter, and I verify that I've got AC at the other end of the circuit breaker. I can verify that before the switch, right at the switch connector for the power switch, I've got AC. But when I plug in the switch, I don't get AC on the other terminal over here, which tells me probably the switch is bad. Sure enough, if I try and measure the resistance of the switch and flip it on and off, I get basically no change. So I'm going to get that out of there and see if I can get it apart, clean it, and if not, I may just have to short out the power switch for the moment. And can always look into fixing that or replacing it later. But for the sake of moving forward, I'll do whatever it takes here to get power to the thing to see if the transformer at least doesn't smoke. From there, I can throw the regulator board back in and start slowly cranking the voltage up and see how that does and make sure these caps aren't shorted or something. So here's the switch disassembled. You have to kind of unbend some of the metal part there, and it kind of comes out of the contact housing, and then there's these moving rocker contacts. You can see the one on the left is pretty dirty, the one on the right is clean only because I kind of swiped my finger across it. So I think that's only part of the problem. The other problem is that the contacts in the housing here are probably just as dirty as the switch, as the rocker contacts, if not more dirty. So I'm going to have to clean those up, and then hopefully I can get these to make a connection again and work properly. And then if I can do that, then I'll put it back in and I'll start testing the transformer. Well, I got the switch back in place, and I gotta say, I hope I never have to take that thing apart again, because there's some tabs you have to bend in order to get the switch apart, and they're really not made to be bent more than assembly at the factory. So, of course, in the process of trying to put the switch back together, they got bent more than they were designed to be bent and broke off. And then I had to try and put these things back together. Anyway, so yeah, hopefully I don't have to touch that again, because it's not going to work out well. The good news though is that the switch is working now. So got the variac turned down, turn it on. And I'll start cranking this up. This is one of the secondary windings of the transformer. Got, some voltage here. What kind of worries me though is that given the circuitry on that power supply board, I'm not entirely convinced that these voltages are correct, because it seems like as soon as you plug that power supply board in, the voltages here are going to produce some excessive voltage on the capacitors on that board. So I may have to keep an eye on that. I think this winding, for example, gets rectified, and the filter cap on there is only rated for 50 volts. So they might be assuming that there's going to be a load on this transformer. That could be part of it. so I'll have to be careful. They may be expecting the voltage to drop from the output of this transformer once it's loaded down. And I don't really want to put a load on this right away until I know that the power supply works. So in terms of that, I mean, I don't want to crank this thing up right away and just throw everything back together and flip the switch, right? So that's the advantage of the Variac, is that I can make sure that I don't run too high of a voltage on any of these caps past their rating as I slowly crank this thing up. They may be expecting this voltage to drop, you know, because I think I can't do the math in my head. Well, I think I've got a calculator here, but if we calculate, you know, 42 volts and calculate the peak, I mean, yeah, that's sitting somewhere up around 60. So that's about what you'd expect to get out of this thing rectified, which, well, that would exceed the rating on the 50 volt cap. And there's also another secondary on this transformer that produces almost 210 volts, and that's being rectified and put on a 250 volt cap. So again, you know, without loading, I think that would just exceed the maximum voltage on that capacitor. So the other possibility is that there is actually something wrong with the transformer causing it to output a higher voltage. The only thing I could think of is that it's either A, miswired, and given this plug indicates 115, I don't think that's the case, or B, maybe if there were some shorted turns in the primary, but usually I think that you'd have evidence of that because the transformer would get pretty hot if you had any shorted turns in it. So I'm going to leave this for a while. Well, I think I'm going to pull the meter leads out. I'll shut the Variac off screen here and pull the meter leads out at least, and maybe just leave this on and make sure that the transformer doesn't smoke, you know, sitting there with no load. Of course, if something really bad happens, at least in theory, this breaker should trip. There's also the fuse in the Variac, so if anything really truly bad happens, I think it'll, you know, everything should be protected from starting a massive fire here. The next step after this, I'll put the power supply board back in and slowly crank up the voltage and look at the voltage on those caps and make sure that we're not hitting some excessive voltage here or excessive ripple or any of that. I've done some testing on the power supply board here. Still got it plugged into the Variac. I switched meters because the battery in my handheld meter is running low apparently, and it was starting to have some issues getting a correct reading. But I've looked at the voltages across the caps, and I don't know, it seems like I'm right. Like, you know, if you crank the voltage up to the normal 120 volts here, that most of these caps are going to exceed their voltage rating, or at least get very close to it. So if I turn on the Variac, and right now I'm across a 500 microfarad 50 volt cap. So as I start turning up the Variac, well, it might help if the power cord was plugged in. So I start turning up the Variac, that's 0.52 volts. Now it's, you know, 2 to 3. If I bring it up to about 50%, we're reading about 50% of the voltage rating on that cap, which seems a little high. Now, probably that's going to drop under load, but until I look at this thing while it's running under load, you know, if I get that far, I don't know what it's going to actually look like. So this is the next cap. This is a 250 volt. Note that I don't have to move the ground connection. All these supply rails seem like they're all off the same ground. So that's a 250 volt, and it's reading just a little over 128 volts, which again is just a little bit over the 50% point for the rating on that cap. Then we got this other large capacitor, the 2200 microfarad 25 volt cap here. And again, just a little over 50% of its rating, which, I don't know, that seems like if I were to go all the way up to, rated line voltage here, and I'm not going to do that, but if I go all the way up to rated line voltage, it would have more than it's rated for, or be at least very close to the rating. Now looking at these few test points here, there's 3 test points, one for ground as well as VDD and VGG. So if I just get on VDD to measure it, I'm reading about 14.5 volts. And if I switch over to VGG, I should say that's negative 14.5 volts. If I get on VGG, then I'm reading about negative 27.5. Now, I don't really know what the electronics in this calculator run on, but given the age, the era it's from, the late 60s or early 70s, I think it's plausible that this is some odd, older variation on maybe CMOS logic. Maybe everything is built with PMOS, and it's kind of some weird logic family that doesn't really have a modern equivalent. And so maybe those are the correct voltages to kind of see for this sort of thing. I don't really personally know. So maybe those are the right voltage. I mean, the regulators seem like they're regulating. I monitored those voltages as I cranked up the variac, and they would kind of hit 14.5 on the VDD rail once I hit about 60%, and then they would stop climbing. So it seems like there's a regulator that's doing its job and regulating. And then similarly on VGG, you'd hit that 27.8 or whatever it read, and it would just sit there and start regulating and won't climb anymore after a certain point. So it doesn't seem like there's something wrong with the regulators. It seems like they're regulating. It's just whether or not they're regulating at the right voltages, something I don't know. Now, there is an adjustment pot on there. I haven't touched that. It wouldn't really do me any good to touch it because, frankly, I don't know what to set those rails to. So for the moment, I'm thinking that, okay, maybe it's plausible. This is some early form of PMOS logic or something weird like that where, they define ground as being, the positive of the supply, and these VDD and VGG are various negative bias voltages that, bias this system and run the logic. And then, the whole thing is therefore some kind of positive grounded convention here, and maybe that's all just fine. Frankly, I don't know, and it doesn't seem like anybody out there on the internet knows either. Now I had, at least not enough to have published information about it. I can't find documents. I found some people with calculators that seem to work, but short of trying to get in contact with them and asking them if they can measure these two supply voltages in their apparently working calculator, I mean, I don't know how to verify that these voltages are correct. So, okay, back together. Here goes nothing, I guess. Turn that on. Turn this down. Let's see if I can rearrange things here a little bit. Okay, that's maybe a little promising. Seems to want to do something. Now, my loaded voltages here are still within the ratings of the cap. They're coming up there on the rating of the cap, but it's not just completely I mean, there's no smoke, there's no fire. That's generally a good sign, but it also doesn't do anything. Tried the reset button, that doesn't do anything. There's a clear button, that's not really doing anything either. Voltage on the what I imagine is the supply for the Nixie tubes is not excessive. That's that 250 volt cap. It's not, you know, anything ridiculous, but it's clear that something is not right here. Seems like, you know, it wants to do something. Like when you at least turn it on, it lights some digits up and kind of cycles through, you know. But then maybe it locks itself up doing something. Now, at least according to some information that I read online, I guess the oscillator for the whole system is on the power supply board. It's likely that they built it out of like discrete components, like they made an RC oscillator or something like that. It's possible that something there is faulty and the oscillator's not running. But I mean, other than that, I don't really know where to go from here. Like I said, I can't find any proper documentation for this thing. It's not like I found schematics. So I may just have to look through here and see if there's some, you know, common component failure that seems maybe likely, and just look at a few components that I think maybe there's a likely failure, you know, like small electrolytic capacitors or something like that, that, I don't know, maybe they're part of a timing circuit or something. That's about all I can probably do. The only other thing is that it could be dirty connections on the various connectors. There's a connector in the back connected to this harness that runs to the display. There's a connector for the keyboard here on the side, and there's the backplane connectors here in the front that join the two boards together. Other than that, I don't know where to go with this for the moment. Well, I'm not exactly sure what I did, but I suspect it has something to do with reseating the cards and the edge connectors. So probably those need to be cleaned, but it seems to work now. I had some more trouble with it. It was like doing the wrong operation, and it wouldn't let me change the sign, but I messed around with the keyboard a little bit, and it seems to be functioning now, so I can, add two numbers. 2 plus 2 is 4. Of course, I can multiply two numbers. That's 12. You can switch it into scientific notation. So it's going to display everything with an exponent, whereas if you flip it the other way, you'll get the result without an exponent unless it needs it. So I think you were to say then it'll give you an exponent. You can do subtraction, of course. Goes negative. You can do division. There's some statistical functions I'm not sure how to use. You can also enter a number in scientific notation. I think you have to put in 2 digits or it doesn't work right. Not sure if that's for fractions or how that works exactly. You can do 10 to the power of, so you can do exponentials base 10 and base e. How you get to the two functions on that key is kind of interesting. I think you have to so, for example, 10 to the 0.3 should be roughly 2. But of course, e to the 0.3 is going to be something completely different. It's about 1.35. So you have to basically, I'm not sure if there's a conversion factor, it does, or something like that, but however it's handling it, basically, if you calculate the exponent, 10 to the 1, it's going to give you 10 to the 1, but if you go hit the second function key, then it'll give you the result of the other function instead. So e to the 1, which is, e, approximately that. Do logarithms as well. Can do base 10, or you can do base e. You got to hit the second function key. Now, obviously, there's some kind of rounding error in there. That should have been, exactly speaking, the result should have been 1. Of course, you can calculate the reciprocal of things as well. You can calculate the factorial. Now, that's kind of a fun function because you can kind of tell that it's cycling through. You can kind of tell that it's cycling through a lot of iterations there. Calculate the square root of things, so square root of 2 should be about 1.4, right? So I'm thinking of the square root of 3, which is approximately 1.7. Of course, working in the decimal domain, it should have no problem getting the square root of square numbers. fairly exactly, I think. Not sure what the XY key does. It's probably for some sort of statistical function. These are some sort of statistical functions as well. I forget what they mean. The other interesting thing is that if we look over here at the faceplate, you'll notice there's these two extra neon lamps all the way on the left, all the way on the right. If we look at the faceplate, you can see what those actually say. It may be hard to see in this picture, but that says error. And over here, again, it's going to be hard to see, but it says overflow in abbreviated form. So let's try to take the square root of a negative number. See how this handles the square root of -1. So it gives you an error. You try to take the logarithm of a negative number, it gives you an error. If you try to take the reciprocal of 0, it gives you an error. If you try to divide by 0, it gives you an error. So there's various error conditions it can recognize, and then it handles overflow separately. If we take the factorial of, say, 99, it'll run through and attempt to calculate it. You see somewhere in the middle the overflow lamp lit up. So I suspect that the answer, and I don't think I have a way to compare it easily, but I think that the answer is really, well, that's a good question. I'm not sure how the overflow behaves. Either the answer is, you know, that mantissa times 10 to the 155th, or it's times 10 to the 255th. It's, you know, it's got to be somewhere in there. You can probably figure that out. Run through this until we get, yeah, well, see, it overflowed, but we're right on the border there of, you know, of 10 to the, well, yeah, 10 to the 99 is, you know, the just outside its range of display capability. It could show you 9.9 to the 10 to the times 10 to the 99, but it can't show you 10 times 10 to the 99. So do 69 factorial, because apparently 70 was just outside its range. Yeah, we are getting just under, yeah, just under its maximum range here. But 70 factorial, I suspect, is 1.19, you know, whatever, times 10 to the 100. Probably also, well, I think you got to clear the error, but 1 point, yeah, let's do 1.0 E99. Well, it's not going to work. And we can multiply that by 5, multiply that by 2. So, like, it gives you the correct answer in a sense, in that you could figure out what it was. But it's going to tell you it overflowed. You know, if you can make an educated guess, you could still use this result and say, well, I know that it was, you know, 10 to the 99, and I know it overflowed upwards, so, you know, it turned into now 10 to the 100th, 1 times 10 to the 100th. I think you can probably see that if you do 1E99 times 1E99, this should give us 1 times 10 to the 198, I believe, so I think all we're going to see is 1 times 10 to the 98th, right, and the overflow light. But it'll still do the calculation, it'll just overflow. Just kind of cool. Yeah, so given that it's working, I think I'm going to try and clean up all those edge connectors. Got some contact cleaner I got to bring in from the garage, and I'll spray them and consider putting some lubricant on there. I think normally I only would do that for switches, so probably skip the lubricant, but I can do contact cleaner and, you know, try and make sure all these connectors are clean and clean up all the edge connectors. And then just going to put this thing back together. I don't know, all the keys seem to be working. I guess I haven't tried them all necessarily, but I think all the keys are probably working. Well, it's all put back together now. I cleaned up the case and cleaned all the keys on the keyboard and cleaned the dust off a lot of the boards inside. And, put it back together and it still works. So I also cleaned all the edge connectors. I got the can of contact cleaner and sprayed them all out and went over the fingers on the board, the tin connections, and just cleaned them off. And it seems to be working fine again, so yep, no problems there. So now that the case is back on, you can see how the overflow light is shining through the overlay here, and also we should be able to, oops, got to reset. You can take the square root of a negative number and get the error lamp lit up. Yeah, plastic is clearly a bit darker shade than it used to be, I think, but other than that, it cleaned up fairly well. There's some scratches. I mean, it's had some use clearly, but I'm glad it worked without much fussing. You know, I guess they engineered the thing pretty well, and everything just held up and lasted for, well, seems like it was made in 1972, so that makes it almost 50 years. That's all there is to it. The only other thing I'll have to do is either find a matching power cord for this connector and put that back in there, or otherwise I'll have to find a more permanent power input solution than what I've got rigged up back there for now. But that's everything otherwise complete on this. Oh, there is also this piece that I've got to glue back here. I taped it to the top so that I wouldn't lose it, but I'll get around to that some other day.